Good afternoon, good morning, everyone. So in part one, I'm going to summarize what we discussed in part one. So this is the Ptolemy's model. Ptolemy's model, there's the Earth. Earth is not at the center of this circle, and it was somewhat away from the eccentric. And then he added another point called equant, which we will discuss. And across the eccentric, or the center of the circle, this epicycle, center of this epicycle moves around. And the planet moves around the center of the epicycle. So planet moves around like this, and the planet is not moving as the center of the Earth. Now Plato said planet path should be circular and should be uniform. And these are philosophers. They just sit in their chair and they just come up with these ideas. He says, you know what, the planet has to go in a circular motion and should be uniform around the Earth. So the planet has to go in, according to Plato, planet has to go in a circle. And then Aristotle added something. And he says it has to go on a circle, but the center of that circle should be the Earth. Ptolemy could not make that work. Ptolemy is an astronomer. He is not a philosopher. He did not sit around and just made comments. He wanted to make it work, observation. So what he did was he moved the Earth a little bit, and that would somewhat represent the elliptical nature of the planetary motion. So now this center of the epicycle goes as the center of the eccentric, and the Earth is here. And then he added another thing called equant. And from that equant to eccentric and eccentric to Earth is the same distance. So what is the equant does? What equant does is that angular momentum of the center of the epicycle is constant when looked at from the equant. So angular velocity. Angular velocity of the center of the epicycle going to be constant when looked from the equant. So the Earth is here. Eccentric is the center of the deferent circle. That will be the circle where the center of the epicycle travels. The equant is there. From the equant, the angular velocity is a constant, not from the center of the circle. So this is Ptolemy's model, and this is not incompatible with Plato and Aristotle's ideas. So this is what we discussed in part one. And so let's go back to Pingree's paper. So we came to Paitama Siddhanta and Vishnu Dharmata Purana. And so Pingree says, in the Paitama Siddhanta of the Vishnu Dharmottara Purana, which is our earliest extant exponent of the Indian double epicycle planetary model. And we said that the Indian double epicycle never appeared in Greek planetary models. It's unique to India. It was probably composed of the first half of the 5th century AD, way after Ptolemy. Ptolemy lived in 100 AD. So the Paitama Siddhanta was written in 5th century AD, 400 years after. The pattern was set for all later texts, except for those belonging to or aware of the Audyapaksha system of the Aryapaksha, which we will get into that later. The orbits of the planets are concentric with the center of the Earth. So now this is somewhat in Aristotle would like it. He would say that's what I said. The orbits of the planets are concentric with the center of the Earth. So if you go to the Indian model, double epicycle. So orbit of the planet is not concentric with the center of the circle in the Ptolemy model, but the Indian double epicycle method, planet is moving in this different circle, and the double epicycle is moving the planet back and forth to create that zigzag motion. So the mechanism here is the planet is moving around a circle which is at the center of the circle of the Earth, but it's not moving in a regular pattern. It moves back and forth, and that back and forth movement is calculated using two epicycles, double epicycles. So this model is compatible with Aristotelian logic. Okay, so that's what PINGREE is saying here. And then he goes on to say so he's saying the single inequalities recognized in the cases of the two luminaries are explained in the Manda epicycle, corresponding functionally to the Ptolemaic eccentricity of the Sun and lunar epicycle respectively. Now this I don't agree with PINGREE here, and most people don't. The Manda epicycle, he is saying, that was obtained from the Ptolemaic eccentricity. I don't see that. We will go into Manda epicycle later in the paper if you keep listening to me to the end. And there's the other epicycle is the Secret Epicycle, two epicycles. That's why it's the double epicycle. So the Secret Epicycle, PINGREE is saying that's regular Ptolemaic epicycle, and the other one is the eccentricity. So I don't see that. I personally don't see that. If they did that way, they butchered it. They totally, the Indians totally changed it. And then PINGREE says the further refinements of the Ptolemaic models are unknown to the Indian astronomers. So he's saying that the two epicycles were the only thing that they did, and refinement of those two epicycles. And then PINGREE goes on to say, if one tries to imagine the geometric model utilized by the Paitama Siddhanta, one immediately realizes that it cannot be cinematic. Now what does that mean? What does cinematic mean? Now if we go to the double epicycle here, now the planet is going along the different circle, and you have another point going around the Manda epicycle and another point going around the Secret epicycle. So these points would move around the planet in a mathematical way. You cannot really see a planet unless you, at that time, if you could have some kind of computer model. Unlike the Ptolemy's model, this you really cannot see the planet moving. You can get it through mathematics. That's what PINGREE is saying here. So where are we? The planet cannot ride simultaneously on the circumferences of two epicycles. So the two epicycles are there to compute the planetary motion. These two epicycles must be regarded simply as devices for calculating the amounts of the equations by which the mean planet on its concentric orbit is displaced to its true position. So the mean planet is that where the mean planetary motion is the motion that it would take over a year, and over a year they would take the motion and then they would divide into a uniform motion per day, and that would be a mean planetary motion. But the planets don't move that way. Planets move half-crescently, and there's a true motion. So the difference between the mean motion and the true motion has to be calculated using the double epicycle method. And then the computation of the total effect of these two independent forces upon the mean planet varies somewhat from one school of astronomers to another, or even from astronomer to astronomer within Paksha. You know, they had the Audya Paksha and Brahma Paksha, two Pakshas, two basic groups that they were arguing. And Brahma Gupta belonged to Brahma Paksha, and he was seriously criticizing Aryabhata on Aryabhata's ideas, which I might get into later on. But the fundamental concept remains clear. The planet is always situated on the circumference of a different circle, concentric with the center of the Earth. That is in agreement with Aristotle logic, because Aristotle said that the planets are going in a circular motion, and that circle, the center of that circle is the Earth. And the double epicycle method is somewhat agrees on Aristotle, because the planet is going around a circle, in the different circle. It has a zigzag motion, but nevertheless it goes in a circle, and that center of the circle is the Earth. So the Indian model agrees with Aristotle. As the planet progresses with the mean velocity above this different circle, at each instant it is pulled by the two epicycles away from its mean to its true longitude. So we have longitude and latitude. The longitude is measured from the vernal equinox. Now, I would assume that you know the regular stuff, which I would do a preliminary if you don't know. And the latitude is measured from the ecliptic. So the longitude is measured from the vernal equinox, and the latitude is from the ecliptic, the height. And so there's a mean longitude and a mean latitude for the planet's location. That is, the planet path is divided into 365 days, and it's a regular mean planet, it's called. But that's not the way the planet moves. It goes zigzag, it goes back and forth. There's a reason for that. That's the retrograde motion, which I would talk about in another. That's basic astronomy, celestial mechanics. That's how we see it. That's how they saw it. But the planets go in an elliptical manner. But we are not at the center of the planetary motion. If we are at the sun, we will not see the retrograde motion. But from Earth, we would see the retrograde motion. That's zigzag motion. And so Indian model agrees with Aristotle. That's the main point that Pingree is making. Ptolemy model does not agree with Aristotle. And then he goes on to say, this is not to deny that the equivalence of an eccentric to an epicycle model had also transferred from Greece to India. Now, this is total speculation. He's saying that the eccentric that Ptolemy had also transported to India, even though we don't really see that in the double epicycle. Now he goes on to say, though it would seem that the transmission was effected by a different text from that from which the double epicycle theory is derived. Now this is what I would call baloney, BS. Now he's coming up with a theory that double epicycle, I don't like to use the word BS for a top scholar like Pingree, but hey, it stinks, okay. Alright, so he's saying that there are no books on double epicycle in Greece. But those books were there, okay. Double epicycle books were there in Greece. They were lost. How the hell That's the dumbest argument that someone could make. If it's lost, it's lost, gone. That's how I look at it. But he's theorizing that, and it doesn't make sense to me. And then he goes on to say, though it is true that in one passage of the Aryabhata in Aryabhata, and I would assume you all know Aryabhata, who was born in 476, clearly implies a double epicycle model by giving the circumferences of the Manda and Secret Epicycles in another. He correctly describes an eccentric epicycle model, and I'm not going to read this one because it really does not affect our main thrust of the point. And then he would say, I would go into this one here. This is the important part. In Greek intellectual circles, there was a clear conflict between the physical theory of motion posited by Aristotle and the cinematic models of planetary motion developed by later astronomers such as Ptolemy. In the DICUSSED, it's a book written by Aristotle. Aristotle claims that the motions of the celestial spheres, which consist of the fifth element, must be uniform and circular about the center of the universe, which we discussed. That is the center of the Earth. So basically, planets move around the circle as the center of the Earth. So basically, that's what Aristotle said, and that's what you see in Indian models. The principle of concentricity is thus added to the principle of uniformity and circularity enunciated by Plato. So the Plato said the planets go in a circular motion and they go in a uniform motion. And then Aristotle added the concentric part. They go in a circle where the Earth is at the center of that circle. And the Plato totally ignored both. So, I discussed all this, so I'm going to skip these. And he goes on various technical details which we really don't need. And there, I would read here, the peripatetic scholars of the 2nd century were much less convinced of the priority of mathematics over physics in determining the true nature of the planetary orbits. Now, who are the peripatetic scholars? The peripatetic scholars are a group of people who believed in Aristotle. What they believed was basically that planets are going around the Earth, and the Earth is at the center of that particular circle that the planet is going. And the Ptolemy's method you saw, that's not the case. An Indian method, that was the case. So we would go into the next. So basically, he's going into little tiny details on that basic issue. So let's go to the next page. I don't see anything to discuss here other than he's basically trying to give finer details, which I would ask you to read yourself, and I could go past these. So basically, I would read the end here. The Indians had to still take into account the problem of varying distances of the Sun and Moon, whose computation is essential for the prediction of eclipse magnitudes. These distances they made to vary inversely with the true instantaneous velocities of the luminaries. So the two luminaries are the Sun and the Moon, and the distances vary because we look at these planets from Earth, and these planets, except the Moon, everything else goes around the Sun. Thereby, of course, as was inevitable, strict concentricity was lost. This fact, however, does not militate against the theory of peripatetic origin of the Indian double epicycle model. So basically, Pingree's theory is, what is Pingree's theory? Pingree's theory is that these Indian models, the planet goes around, this is the planet reference circle, and the center of the Earth is here. Planet goes around the Earth, and the center of the circle is the Earth. And these two epicycles are there to do calculations. Now, in the, there's another double epicycle model, and the planet is going around a circle, and the center of that circle is the Earth. Now, these epicycles are there to move these planets back and forth in this epicycle using equations. So this is agreeing with the peripatetic scholars in Greece. And so what Pingree is saying, that the peripatetic scholars had a book which is lost today with same exact model, and that was translated to Indian Sanskrit, and Indian took it from there. So it's a lost book. I think that theory is baloney. I don't believe in that theory. But that's basically the Pingree's theory. So we are going to look into Sen and Krak and various other Indian scholars, what they say, and then I'll give my own opinions. Thank you very much for listening. So join for part 3.